Hello and welcome to another video. In this video we're back to doing easy problems and we're going to be doing destination city. So you're given an array of paths where paths I is city A, city B means there exists a path going from A to B. Return the destination city, that is the city without any path going to any other city. It is guaranteed that the graph of the paths forms a line without any loop and there will be just exactly one destination city. So for this example the destination is Sao Paulo because you can go from London to New York, New York to Lima, Lima to Sao Paulo. And for this one, you can go from D to B, and then from, so I think technically you can take a bunch of different routes. So you can go from, like they say here, D to B to C to A, you can go to B to C to A, you can go to C to A. So really, it's kind of a straightforward one. Let's just figure out, like, what are the requirements for destination? Destination has to be in second value of a path, right? In order for a destination to be there, you have to have some path that goes from X to Y, and it has to be like this Y. So that's one of them. And the other one is it can't be in the first value. Right? So if it's a destination means you can't go from it to any other path, right? This is the city without any path going to another city. So essentially, it has to be in the end, and it can't be in the start. So it's a pretty easy problem. So if we just look, like, let's take a look at what things are in the end here. New York, Lima, and Sao Paulo. Well, what's not in the start? Only Sao Paulo, right? London, New York, and Lima are. Sao Paulo is not. Let's take a look here. What are our end nodes? We can even write them down. So our end nodes are CBA. Well, which one out of all these, one of these has to not be in the start. So B is in the start right there. C is in the start right there, and A is not. And here, Z is not in the start. So that's really all you have to do. You have to basically return the node that is in an end of a path and not in a start. And so because that's all we have to do, we can easily do this, right? We can just have the easiest way to do this is have a set of start nodes, set of end nodes. And so you can actually do a set difference here. And I actually got asked this on my Google interview to do this. So basically if you have two sets, let's say you have set A and set B. And so in this case, we'll have like a start set and an end set to symbolize those. In order to get all of the nodes that are in start and not in end, you can just do a set difference. So you can say, let me just get set A and so set S and subtract E. And this will give you all nodes in S and not in E. Similarly, you can do the other way where this would give you all nodes in E and not in S. And this is the one we would want, right? It wouldn't be all, yeah, it would be all nodes. So, except there's only going to be one node, right? I think they tell you there's only one destination city. So there's only one node that is an end node and that doesn't have a start node. So that's essentially what we can do. We can just get a set of start nodes, get a set of end nodes, and then we can just subtract E from S. Now, if you're doing this in another language, if you're not doing a set difference, it's still pretty straightforward to code, right? Like, let's say S was your start, E was your end. You would say, like, give me, or you would say, like, loop through all nodes in E, find node that is not in S, and return, right? There's only going to be one. But in Python, you can just do the set difference in that. And I actually was like, can I code it like this? Can I code it a few lines? And he said, no, you can just use the set difference. So I didn't know that, and I think I got marked down for that. So something useful if you are doing this in Python. Okay, so now we can code it up. So essentially, we're going to get a end nodes and a start node. So we'll say like start, or we'll call like source equals set, destination equals set. Then we'll say like for start end in paths. Let's just add all the starts to source. So source.add start, destination dot add end. And so now our start nodes will be in start, our destination will be in, or all our end nodes will be in destination. Now we just need there's only going to be one node that's in destination that's not in start, so we can just do return destination minus source. Now, here, this will give you a set. So you'll have a set of one node, but you want to convert it, you want to actually get that node, right? So you can just convert it to a list. Convert it to a list. Now we'll just basically have an array of one node. So you'll have an array with one item in there, so you want to just return the item, so you can just index it at 0. And that's how you do that. And let's see how this goes. And there we go. And if we just click submit a few times, then we do better. So, as always. So, a pretty straightforward one. Back to doing easy problems. But yeah, essentially, once you realize that you're just looking for the one node that's an end node that's not a start node, pretty straightforward. You can use 2 sets. You can use 1 set. You can, a bunch of ways, because the constraints are super easy. You can do a nested for loop if you want to. But essentially, let's go over the time for this one. So essentially, we go through our paths, which is O of n. And this situation, this set difference, so basically if you wanted to code this up, you would say like for node in DST, right? If node not in SRC, do something. And so this would be the length of the destination nodes, which is upper bound by O of n. This is O of 1, this is O of 1, so this set difference thing is O of the bigger set, or O of the set that you're doing the difference of. So it's going to be the one, this one. But either way, this part was O of n, so it's O of n. And the time, O of n again, because essentially what's going to happen here is we'll have n nodes in the start and nodes in the end. There will be one node in the start that's not in the end, and there will be one node in the end that's not in the start. Because our graph basically always looks like A to B to C, right, and so on. There are no loops. So we're basically just looking for this node over here that's at the very end that has no paths coming from it, but has a path coming to it. Similarly, there's also a node over here that has no path going to it, but a path going from it. But that's not what we're looking for. We're looking for this D. Okay, and yeah, that's going to do it. So hopefully this was helpful for you. And if it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.